All right, so I'm going to go through. I have the study guide uploaded on the left. I'm just going to pick some random questions and go through. This video is going to be made into several different videos because I just don't want to have one video that is like an hour long. Not that it's going to be an hour, but I just don't want to have one video that's just really long. So I will just break these up randomly throughout. So then when that happens, I'll just make sure I label the videos from this number to that number. All right, so the first one that we're going to cover is this number 2. So it's not asking you to multiply these because it's separated by this minus sign. So we are subtracting this polynomial from the polynomial before. So in order for us to subtract, we need to first distribute this negative sign in. So this becomes negative x squared plus 6x to the fifth plus 8. Actually, let me erase this and give myself a little bit more space. I'm going to run out of space if I do it like that. So it'll be negative x squared plus 6x to the fifth plus 8. And then minus times a negative is equal to plus 14. Minus times a negative is equal to plus 13x squared. And then minus times a negative is plus 3x to the fifth. Right? Then we need to look for common terms. Well, we have 6x to the fifth and 3x to the fifth. We always have to write our highest power first. So 6 plus 3 is 9x to the fifth. All right? Then our next one we have is going to be 13x squared and negative x squared. So then 13 minus 1 is plus 12x squared. And then our last two are constants. So 8 plus 14 is plus 22. And that is your final answer. Do not multiply these. Right? If you look here, this says multiply and simplify. This one just says simplify. And there's nothing in between them, which is how we know that we need to multiply. All right, so for these, I'm going to do number 4. We will distribute 4x times 4x is 16x squared. 4x times negative 5 is minus 20x. 5 times 4x is plus 20x. And 5 times negative 5 is minus 25. The two middle terms cancel out, so 16x squared minus 25, and that is your final answer. All right, then to rewrite this as an exponential form, that means that we cannot have a fraction and we need to just have our base. Well, our base is what's inside of our radical. So remember, it's power over index. So we know it's going to be our power is 1 and our index is 6, but then we would have a fraction of 1 over 10 to the 1 over 6 power. And we need it to be just our base, so it would be 10 to the negative 1/6 power. Right? To evaluate this, I know I'm going through this quickly, but if you need to, just rewind the video. To evaluate this, we will rewrite it in radical form. So it's power over index. So since we have an index of 2, I know we're taking the square root, and it's being raised to the third power. Well, it's easier to take the square root of 25 than it is to raise 25 to the third power, and the square root of 25 is 5, so 5 cubed is 125. All right, I will pick this one to go through, number 8. So first we need to distribute the square to every single term inside of that parentheses. So it becomes 4 squared times u to the negative second power squared times v to the negative fourth power squared. All right, so then this will give us 4 squared is 16. And remember, power to a power we multiply, so it's u to the negative 4 and v to the negative 8. We cannot leave these in negative exponents, so then we need to rewrite these as their reciprocals. So it becomes 16 over u to the 4th power, v to the 8th power, and that is your final answer. All right, the one that I will do for this one is I'm going to do the first one here, number 11. So we multiply our likes with our likes, so 2 times 7 gives me 14. And 10 to the second power times 10 to the negative first, when we multiply, we add them. So that will be times 10 to the first power, because 2 plus negative 1 is equal to 1. But when we do scientific notation, we can only have a digit in front of our decimal that ranges between, I'm going to put number, it's got to be less than 10 but greater than 0. So it can be, and it's got to be an integer. So it can only be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Right? So then from here, we need to take our decimal and we move it one place, so it gives me 1.4. Well, now we need to figure out what 10 is being multiplied by. Remember, when we make our number smaller, we have to make our power larger. So since 1.4 is smaller than 14, we will add the number of decimals that we move, which is 1, and it becomes 1.4 times 10 to the second power. All right, moving on to the next one, true or false? Well, integers are only whole numbers, but since it says positive integer, this is false because negative 2 is negative. Rational means it can be written as a fraction. Well, 4 can be rewritten as 4 over 1, so this one is true. Irrational means it cannot be written as a fraction, and this can be rewritten as a fraction, or it is a decimal that never ends or never repeats, so this is false. It is not irrational, or it is rational, not irrational. The square root of 4 we know is equal to 2, so 2 is a natural number, so that is true. All right, that's the last thing I'm going to do for these. Now we're going to move on to the number lines. All right, I'm only going to do 2 of these. I will do I'll do D and I'll do C. All right, so for C, we have to draw our number line first. All right, then we're starting out at 3, and it tells me the set of all x's such that x is greater than 3, and x is a natural number. So that means it's only whole numbers. So that means we will have 4, 5, 6, and 7. And then since it's just greater than and it's not equal to, it's going to be an open circle here, and then it'll be closed circle on every single one after that. Right? If you were to write an arrow continuing there, that would let me know that it is continuing in the same pattern. Or what you could write, which is the answer that I would actually prefer, is if you wrote dot, dot, dot after it, because that means we're continuing in the same pattern, which means every whole number counts. All right, so that is the answer to C. And then the answer to D, when there's no set written, so it's a set of all x's such that x is greater than or equal to 2 and less than or equal to 6, but there's no subset, there's no, it's not telling us what set it's part of, that means it's automatically real. So then we will go from 2 to 6, and the good thing about this one is, well, first off, it's greater than or equal to, so it's colored in, less than or equal to, so it's colored in, and when it's real numbers, we just go ahead and draw a line because every single number in between there satisfies, 2.5, 2.4, 5.5, and so on. When it's natural integers, we have to do the points because we cannot include any of our decimals. All right, I'm just going to pick 2 of these. I will pick A, and I will pick union, and then I'll do C. All right, so when it's union, that's the U, it doesn't matter. You just color it in. So A, I'm just going to color in what A is. So A is this entire circle. All right, when it's union, it does not matter. Any of our answers will satisfy. So you don't have to worry about where they overlap or where they intersect like we're going to do in the next one. All right, so it will be any of that is our answer. And then it says union B complement. Well, B complement is anything outside of B. So that means we can color in the rest of our universe. So this would be our coloring and our answer for our final answer, everything that's outside of just B. All right, the next one I'm going to do in 2 phases. So I'm going to start, C will be here. First, I'm going to color in A complement. So A complement, because this one says intersection. So intersection is different. We need to look at where they overlap. All right, so here is our A complement. It's everything outside of A, but everything that's also inside of B. Right, then underneath of it, I'm going to do where it says B. So B is everything in here. So then our final answer is where do they overlap? It's where will it satisfy both? And that is this portion of our B. It's just our B because that's the only part that those 2 overlap or share. So that means our final answer for C is this third part. And it'll be that there. All right, so this is the answer for A, this is the answer for C, and this is just a work to find out C. All right, I'm going to do 17 and not 18. So in this one, we're talking about 40 students. We have in a class of 40 students, 23 have dark hair, 18 have brown eyes, and 26 have dark eye, brown eyes, dark hair, brown eyes, or both. How many students have? All right, so what you need to do for this is you need to create your Venn diagram. We have our universe, and we know that there's 40 total students in the universe. We have our dark hair, and we have our brown hair. Right? It tells me that 26 people have dark hair, brown hair, or both. So that means all of this region, this region, and this region has to add up to 26. So the way that we solve this is it tells me 23 have dark hair. So that means there's 23 people in total in this circle here that has dark hair. Right? Then it tells me that 18 have brown eyes. So what we do is we add them together, 23 plus 18, and that is then equal to 41. Since we only have 26 total people in that region, we need to figure out how many duplicates we have. So we would take what we get when we add both of those, and we subtract how many people we know we have. That means 15 people had to have both. So that means I can write 15 here. Now I look back and say, well, if 23 had dark hair and 15 is already included in here, 23 minus 15 is equal to 8. So that means 8 people only have dark hair. If 18 have brown eyes and 15 are already included here, that means 3 had to only have just brown eyes. So how many people have dark hair and brown eyes? That's the part here that they overlap, so it's 15. Right? Then the last part is, if we have 26 people that have dark hair, brown eyes, or both, we have 26 people here. That means 40 is the total number of students that we have. If we subtract the 26, that means we have 14 students that don't have dark hair or brown eyes. So how many have neither dark hair nor brown eyes? That would be 14 students. All right. Moving on to the next one. All right, so for this one, I'm going to go through A. I'm not going to go through both. B, I'll do later on down here. Actually, I'm not going to do A or B for this one because they all kind of get done down here. All right, so I'm going to just do 23. All right, 23 will cover both of these in all types. But let me do this one first. We cannot take the square root of 24, and we cannot take the square root of 6 as is. So what we can do, though, is we can rewrite them since they're both square roots underneath the same radical. And 24 divided by 6 is 4. And then we can take the square root of 4 and say it's 2. So this would reduce to 2. Now, you can use your calculator on a test. However, if you just give me 2 as an answer and you do not show this and you do not show this, you will lose points. You won't get any credit. Right? You have to show me your work. When a calculator does it all for you in steps like this with radicals, especially, you have to show me your work. Right? And the directions on the test are pretty clear, I think, with that as well. All right, so for this 23, we have 5 minus 1 plus the square root of 7 times the square root of 7 minus 2. So the first thing we have to do for this before we can subtract anything is we need to multiply. So 1 times the square root of 7 is square root of 7. 1 times negative 2 is minus 2. Square root of 7 times the square root of 7, well, since they're the same, we can multiply what's on the inside, and that would be 49. And the square root of 49 is 7, so that would give us plus 7. And then square root of 7 times negative 2 is minus 2 times the square root of 7. Now remember, this was all being subtracted from this out here. So then we would have to distribute the negative sign to each of these. So this becomes 5 minus the square root of 7 plus 2 minus 7 plus 2 times the square root of 7. Then we combine like terms. Well, when we're adding radicals, the index needs to be exactly the same and the number on the inside. So we can add these together because they're both the square root of 7. So negative square root of 7 plus 2 times the square root of 7 is equal to just the square root of 7. Then 7 minus 2 is negative 5, plus 5 is 0. So there are no other numbers. It is just the square root of 7. But remember, if there was a number, our number would go out front, and we would write the square root of 7 after it. All right, let's move on to the next type. All right, I'm only going to go through a few of these. I'm just going to randomly pick them. Let's just say 15, let's say 30, and 33. All right, so for 15, you need to reduce your numbers out front, and then you need to get rid of, reduce your variables as well. So 18 and 12 both are divisible by 6, so that means 6 goes into 18 3 times, and 6 goes into 12 twice. So we can reduce this to 3 over 2. Our rule when we are dividing is we would subtract, which then means I'm left with f to the negative 1, which then means it will become 1 over f to the first power. Or we have 3 here, and we can remove 3 with here and know that we have just 1 f remaining. And that would be your final answer. All right, the next one is a little bit different because we have to factor. Let me erase this answer as well. All right, the next one we have to factor. So the next one we're left with 3x minus x squared over top of 9 minus 3x. So whenever it's broken apart by a plus or minus sign, these ones are not. These ones are all being multiplied, so you don't have to really worry about factoring them when they're not being broken apart by plus or minus. When they are, you can't just start crossing things out, but you need to factor. And in here, I have an x that's common between both, so I can factor out an x. I'm left with 3 minus x. Here, I have a 3 that's common in both, so I can factor that out. I'm left with 3 minus x. Now, since we removed since these are being multiplied and they're factors, I can cancel these, and I'm left with just x over 3. Right? The difference is these are already factors, and these are not, but we are adding and subtracting them. So we need to get their factored form in order for us to cancel out. Because division and multiplication are reciprocal, or are your inverse operations, and they undo each other. But addition or subtraction and division, they do not undo each other. So that's why we can't do anything until we get its factored form. All right, the next one I'm going to do is we have 6x squared plus 7x minus 3 over top of 2x squared plus 7x minus plus 6. All right, so once again, these are being broken apart by addition or subtraction, so we need a factor. So for this one, since we have a trinomial, we're going to factor it using the x method. 6 times negative 3 is negative 18. The number in the middle, remember, always drop to the middle. So numbers that multiply to negative 18 and add up to 7 will give me 9 and negative 2. And then we divide each by the number in front of our x squared. So we divide each by 6 and we reduce. So 9 over 6 reduces to 3 over 2. And negative 2 over 6 reduces to negative 1/3. We started from the bottom and now we're here. So 2x plus 3 times 3x minus 1. And we do the same thing for the bottom one. 2 times 6, well, 2 times 6 gives me 12. The number in the middle drops. What numbers add or multiply to 12 and add to 7? Well, that's 4 and 3. And then we need to divide each one by the number in front of our x squared. So we divide each by 2, and that will give me 2 over 1 and 3/2. So now we can write this in. We started from the bottom. Now we're here. So it's just x plus 2. And then this one, we started from the bottom. Now we're here, and it's 2x plus 3. After we factor, we look and see, do we have any common factors? Yes, 2x plus 3. They reduce and cancel each other, and now it's just 3x minus 1 over x plus 2. All right, that is going to be it for this video. So the first video is going to go between 1 and 33. All right, I just want to make the videos a little bit shorter. I think this is like 17 minutes right now, so I'm just going to end it around 20 minutes for each video.